Let's do the lesson on further vectors. Okay, so let's get started on this. Further vectors. So we've kind of learned a lot about vectors already. We've learned about their magnitude and all that kind of stuff. Now it's just how do we represent them in geometry, things like parallel vectors, scalar multiples, that kind of thing. So further vectors, just some more trickier problem solving, that's all this is. Okay, cool. So here we've got an example. It might look familiar, this example. Just pretend that you haven't seen it before. Okay, so in the diagram, we've got FA, EB, and DC, and they're parallel. FA, which one? So FA, EB, and DC are parallel. And you know they're parallel as well because they're scalar multiples of each other. Because if you take B and you times it by a scalar, which is 3, then you would get 3B. Same thing if you took B and you times it by 2, the scalar 2, you would get 2B. If you took 3B and you multiplied it by 2/3, you would get 2B. So scalar. So notice that the 3 is a scalar and the B is a vector. So this is like 1B, but we just say B. This is scalar multiple of B, which is 3 times B, vector B. And remember, bold B is a vector, and 2 is a scalar, and so on. Just reminding you of scalars and vectors. And there we go. So pretty much what they've said here is on the diagram, but always just read it just in case. AB equals ED, which is A. AB equals ED, and they're both A. Good. FA equals B. FA equals B. Good, it's drawn on there already. EB equals 3B. Where's EB? EB is 3B. And DC is 2B. So always just read over it just in case maybe they added something that they haven't drawn on the diagram. So don't trust that it's always drawn on the diagram. Make sure to read through it and check it's on there already. Express the following vectors in terms of A, B, or A and B. FE. So where's FE? Let's have a little look. FE, many different ways you can get to FE. You could go here to here to here, and they're all labeled already. So many, as I said, that might be one way you want to do it. So I've chosen to do that. I've gone F to A plus A to B. Don't forget to draw your little arrows above. Otherwise, if you don't draw the arrows above, it's not a vector anymore. AB just means a line AB, but with the arrow, it means vector AB. So FA plus AB plus BE. So FA is B plus that one is A, and it's going against the arrow now, so it's minus 3B. So B plus A minus 3B, because you're going against the arrow here, whereas here we're going with the arrow. And then you combine like terms. A is just A, B minus 3B is overall minus 2B. So overall the vector FE is A minus 2B. Sometimes it might be helpful to write it in on the diagram, so if you find it useful, write in A minus 2B here. Maybe just write it lightly just in case, and it's in case you might forget that you've got the answer to this one already. And it might be useful later on. BC. BC, where's BC? Here it is, BC, BC, BC. So lots of different ways you can do it. You can go rant, rant. You know this one now, rant, rant. These ones are already labelled, so this is a bit shorter. So you'll get the same answer as if you just go from here to here, here to here, and here to here. So let's see, pathway I'm showing. I'm doing BE plus ED plus DC. Don't forget your little arrows on the vector signs to make it a vector. And it's going against this arrow, so it's minus 3B plus A plus 2B, and then collect your little like terms. So it's minus 3B plus 2B. That's right, it's minus B. So overall, we've got, when you collect your like terms, it's A minus B. If it helps, write that in, A minus B here, because that's BC. FC. FC, ooh, over here. You could go or you can go because you know all of those, or you could go or you can go You go whichever way you like, because you could go anyway, because you know all the sides now. You know FE, you know BC. The path I chose to take, I chose to go FE plus ED plus DC. That's my choice. So FE is this one, A minus 2B. So we've got FE, A minus 2B plus A plus 2B. It's all going with the arrows. A plus A is 2A minus 2B plus B plus 2B. Cancels out. There you go, you've got 2A. Now we've got, so that's FC going rent, rent. DA is like similarly going rent, rent. many different ways you can go. You get the same answer either way. Which way did I go? I chose to go. What did I do? I went DE first, so I went DE, and then I went EB, and then I went BA. I just went with the original vectors that were drawn in there. That's why I did it that way. So we've got against the arrow, so DE is against the arrow, so minus A plus 3B minus A. Combine your little like terms, what would this become? That's right, you'll get that one on 3B minus 2A. It's pretty cool. Okay, another example. In a triangle XYZ, the midpoint of YZ is M, so just be aware that's a midpoint there. If XY equals S, drawn in, and ZX vector equals T, that's drawn in yay. Find XM, where's XM? XM in terms of S and T. So many different ways you can do it. XM. So we can either go here to here to here, or we could go here to here to here. And we know these sides, so they're fine, but we don't know this side. But overall, we could come up with something for this line here, because we know that going YZ, for example, is that plus that. And or alternatively, I did the opposite, I did ZY. So on the side, I've worked out what ZY is. ZY equals, it's easy, a bit easy to go with the arrows. That's why I chose to do vector ZY instead, because then I go T plus S, because we're going with the arrows. And then so halfway across here, half of this would be half of T plus S. Anyway, let's keep going. So XM is what we're actually asked to do. I worked out ZY on the side because I knew it was going to be useful, and I've kind of popped it where the side is. XM, as I said, different ways you can do it. XM, I've chosen to do XZ plus ZM. XZ plus ZM, because I already had ZY, so I wanted to go in the same direction, but you could have gone that way, no problem. So XZ, you can see is going against the arrow, so XZ is negative T, and then plus half of ZY. ZM is half of ZY, so let's write that in. So it's negative T plus half of ZY. It's okay, because you worked out, why did I write that twice? So you don't need to have written it twice, that's fine. So negative T, you didn't even have to write this step at all, you could have gone straight to that, because you worked out what ZY is on the side here. So negative T plus half of this. And then you might want to expand. If you do a half times that, expand the brackets. Negative T plus a half T plus a half S. And then you've got to add things together. What's negative 1T plus a half T? This is where your number line stuff's going to be really helpful. So do it carefully. What's negative 1T plus a half T? That's right, it's negative a half T, and then we've got plus a half S. So it's just nice in the answers to have the positive at the front, but it's not wrong. If you wrote negative a half T plus a half S, not necessarily wrong, but you'll probably find answers tend to like to, if there is a positive answer, they like to put it at the front. So a half S is positive, and 1T minus a half, minus 1T plus a half T gives you minus a half T. That's where you land on the number line. All right, another one. In the trapezium PQRS, PQ is parallel to SR. Mind you, that's what I'm asking down here, but I imagine you weren't told that. Okay, PQ is parallel to SR. That's just the case for trapezoids. You have one pair of parallel bases. PQ equals A, so good, that's drawn in. SP equals B, and SR equals 2A. So again, you always just check, is everything written here appearing on the diagram already? Because if not, you might want to draw it in. Express the vector RQ in terms of A and B. Where's RQ? RQ, cool. So going from R to Q, you're going starting at R and you're ending at Q. So you're going this way, and that way. So you're going against the arrow, with the arrow, and with the arrow. So I like to write out my little plan. Why do I write R, LP? That's weird. Hang on, just 1 second. Okay, sorry about that. I just, by mistake, pasted in my wrong answers. Okay, so back to here. So ignore what I'd written before. Hopefully you haven't written that down. So express the vector RQ in terms of A and B. So there plus that plus that. So what would make more sense is it's RS. RQ equals vector RS plus SP plus PQ. And so against the arrow, with and with. So minus 2A plus B plus A. And minus 2A plus A is minus A. And again, you'll find that textbooks tend to like to write that if there is a positive part of the answer, they'll put it at the front and a negative at the end. So B minus A, it just looks nice. That's all. So already I kind of had that written up here, which is a bit boring. But what can you deduce about PQ and SR? PQ and SR. So as they're scalar multiples of each other, that's why they're parallel. So maybe the way I should have reworded that question, I maybe should reword the question to be, how do you know that they're parallel? Okay, so again, you might have noticed that I've just, from current slide, so that's what we had already. So notice that I've reworded the question, so hopefully on your copy you've got this question instead. How do the vectors here show you that PQ and SR are parallel? It's because we know already that they're parallel. So how do the vectors show you that they're parallel? So as the vectors, these two vectors, if they're scalar multiples of each other, it means they're parallel. So notice this vector, if you just multiplied it by a scalar, for example, 2 or 3 or 4, and it gives you a vector that's parallel, all collinear to it, but in this case it's a trapezium, so parallel, not collinear. So the scalar multiple in this case is 2. So if you took this and multiplied it by the scalar multiple 2, you would get this vector here, which is 2a. So notice here is the scalar multiple and here is the vector. So as they're scalar multiples of each other, they are parallel. So if you can prove that they have scalar multiples, some example of two vectors that might be scalar multiples of each other are, for example, b and 1/2 b, because the scalar multiple would be a half. Okay, so yeah, if they're scalar multiples of each other, then they're parallel or collinear sometimes. Here you go, another little example. So we've got AB is 2p, good, that's drawn on there. BD is q minus 4p, and DC is 4p. That's all drawn on there, great. Express AC, AC is this line here, in terms of p and q, giving your answer in simplest form. Okay, so let's minimize that. So giving your answer in simplest form, so we want AC. What's a pathway that we can do to get there? We don't know this one, we don't know that one, but one way we could do is we can go junk, junk, junk. So, and the reason I chose this pathway is because the vectors are already labeled on there. So that's just easy. So let's write out our plan. I always like to write out my plan to keep myself on track. Otherwise I could maybe forget to fill in part of it. Like I might forget to write in q minus 4p if I didn't have this plan there. So vector AC, and also just so I get familiar with writing this kind of notation too. So when I write a vector, I'm in the habit of writing the arrow on the top. AC equals AB plus BD plus DC, and it's all with the arrows this time, so just add them together. 2p plus q minus 4p, you don't have to have it in brackets, plus 4p. I just put it in brackets just to show that this is all one vector, but you don't need the brackets there. Then combine the like terms. What's 2p? 2p minus 4p plus 4p. That's right, it's just 2p and then plus q. So that one's done. And then you're asked to express AC, giving your answer in simplest form. Means just make sure you've collected the like terms, which to be honest you have to automatically do anyway. So even if it didn't say give your answer in simplest form, you would still have to automatically simplify it. That's what you should always do. Great. Next one. ABCD, it's a parallelogram, as you can see. AD is equal to, AD equals A, and DC equals B. P is a point on AB such that AP is half of AB. So what do you think that's telling you about this point here? That's right, it's telling us it's a midpoint. It's telling us that this vector is half of AB. So hence P is a midpoint. It's just another way of expressing it. Q is a point on DB such that DQ is 2/3 of DB. So meaning that from here to here is 2/3 of the way along this whole thing here. So yeah, Cool. Let's move on. Express the following vectors in terms of A and B. PD is here. So different ways you can do it. You can go right around like that. Might be easier to just go back here and up there. Because PD is like going zhunk, zhunk. And it's a parallelogram. So this bottom one as well is B. So it's like you're going backwards by a half B, because P is a midpoint. So all the way across here would be minus B. So just from here to here is minus a half B, and then plus A. So we've gone P to A plus A to D, which is, as we said, negative a half B, because it's the same as this one but halved, going backwards, plus A. Let's put that in there. Again, like sometimes in the answers, I'm just in the habit of doing this just so you understand that in the answers sometimes they think it's a bit nicer if the positives at the front and the negatives next to it. They think it looks a bit nicer than doing that. It's just considered to be a prettier answer. So A minus half B is the same as minus half B plus A. Just looks more elegant. Next one is DQ. So remember DQ is 2/3 of the way along. QB would be 1/3 of the way along, and so on. So what you could do is you could just work out what's a vector for DB, and then DQ would just be 2/3 of that. So going from D to B is kind of like going zhunk, zhunk. So like minus A plus B, because plus B is the same as here. Minus A plus B, and then so D to Q would be 2/3 of that. So as I said, D to Q is 2/3 of DB, according to this. And DB, as we said, is just D. Well, you could do it this way. I just did it this way in my working out. Before I was saying this way, same as if you did that way. So DB is the same as DC plus CB, which is B minus A. So because it's minus A, it's going against this one. So plus B minus A. So we need to work out what's 2/3 of that. So see, what I've done is I've just substituted in, on the side I worked out DB, and now in this part it's still 2/3 here, and then multiplied by DB, and DB is B minus A. Then you could expand, or you could just leave it like that, not such a big deal. Not wrong, if you had the expanded version, you would say 2/3 B minus 2/3 A would be your answer. That example is being continued, so what I've done is I've drawn the picture up here again. And it's still the same question as before. So just part B. Express the following vectors in terms of A and B. PC this time. PC. PC is pretty easy because we could just go bleh, bleh. That's one way we can do it. Did I do that? Yep. I just chose the easiest path because we know that that's a half B according to this one. We know that that's plus A according to this one. So PB plus BC is a half B plus A. That's easy enough. And then PQ. So many different ways you can do it. You could do a half B, and then you could do minus a third of that DB one, or you could do minus a half B, so that would be plus a half B, and then minus a third of DB, or you could do PA plus A plus 2/3 of DB. Let's see which way I chose to do. I chose to do PB. No, I didn't. I went this way. I went PB plus BQ. That's the way I chose to do. You'll get the same answer either way. So equals PB plus a third of BD. BD is going this way. Or minus a third DB. BD. Where's BD? BD, just reminding us as before, this is what we worked out on the previous page, but we just did DB instead. Just reminding us, BD is the same as BC plus CD. So minus A plus B. No, what am I saying? Plus A, because it's going with the arrow, and minus B. So BD is the same as BC plus CD, which is A minus B. And so we're going to substitute that into here. So PB, we know, is a half B, because it's going in the same direction as B. And then plus a third, A minus B, a third of this one. then I would expand a third times that, a third times that. So we've got a half b we carry down plus a third a minus a third b. And then you've got to use your fractions. So it's a third a at the beginning, but what's a half b minus a third b? So you've got to use your kind of like knowledge of fractions. So we'll need our common denominator. So I'll put the b's together. It's a third a still. A half b is the same as 3/6 b because the lowest common denominator is 6. And a third b is the same as 2/6 b. So see, we don't need to change this one to 2/6 a because we're not adding it. We're just leaving it. We just are collecting the like terms. So 1/2 b becomes 3/6 b. 1 minus a third b becomes minus 2/6 b. So 3/6 minus 2/6 is 1/6. So 1/3 a is still there, and that minus that is a 6th b. So good practice of your fractions and lowest common denominators and that kind of thing. So what do your answers to BI, this one, and BII tell you about the position of point Q? So PC is what we found. PC is what we found in the first one. PQ is what we found in the second one. Have a look, see, are they scalar multiples of each other? Could you multiply this by something to get that exact thing? So try to think, if you did, that times what would have made 1/3 a? So that one, a times a third, would make a third a. So does this times a third equal a 6th b as well? Because then you would know that this is a scalar multiple of that. So what's 1/2 times 1/3? 1/2 times 1/3, 1 over 2 times 1 over 3 equals 1 times 1 over 2 times 3, which is 1/6. So it seems to be that this whole thing multiplied by a third equals this whole thing. So what that we've done is, as they are scalar multiples of each other, so in this case they're not parallel, because see, P to Q, P to C, they're not really parallel, they're actually on the same line. So the way it's drawn is not to scale, of course. Q would be more so here. So it would be more, so the way it's kind of drawn, it would be more that Q would cut through. As you go from P to C, you would cut through Q, because they're collinear, they form a straight line. And we know that because they're scalar multiples of each other. They're not parallel, because parallel would mean they're separated. But here, they both start from point P. So these two start from two different points, but PQ starts from the same point as PC. So they're actually the same line. So Q is the point, such that PQ would equal 1/3 PC. That's another thing too. And because it's a scalar multiple, because they're scalar multiples of each other, that kind of business. That one's pretty tricky. Let's move on. ABCD is a square. So it's good to point out it's a square, if you couldn't see that. E is a midpoint of AB. So E is a midpoint of AB. And ED, where's ED? ED cuts AC at F. That's already drawn on there, good. The point G is on AC, such that BG is parallel to ED. So meaning that these two lines are parallel. That's all that means. They've also said AD equals P, and that AB equals Q. So express in terms of P and or Q, AE. AE is this one here. And what did they say? Notice that E is a midpoint. So what did they say AB was again? That's right, they said AB equals Q. So you might want to mark that in there, AB is Q. And they said that E is the midpoint between that one. So AE, of course, must just be something easy. It's a half Q, because it's halfway across. ED, where's ED? ED here. ED is here. And we know that AB is Q and that AD is P. So we can say EA plus AD is the same thing as going from E to D. So EA is negative a half Q, and AD we know is P, because we know that AD is P according to this. So minus a half Q going from here to here, plus P. Remember, a nice way that they like to write the final answer is they like to have the positive at the front and the negative there. Just the same thing, same answer as if you did that one. And then CA. CA is pretty easy. So many different ways you can do it. You can go CD plus that. you could do that plus that. So many different ways. What did I do? I did CD plus DA. So CD is going against the arrow, so it's minus Q, and DA is going against the arrow, so it's minus P. Oh, you're just pointing out that that's Q, so going up, I should have had the arrow going that way on there. So minus Q. Minus Q minus P, they're both negative, so it doesn't matter if you write minus Q minus P or minus P minus Q. I tended to put it in alphabetical order in the end, but no big deal. It's okay. Almost there. Another example, in the diagram, the point C on OA, where's OA? The point C is on OA, such that OA is 3 times OC. So if this whole length is 3 times that little length, you can think this as being 1/3 of the way along, and this one as being 2/3 of the way along. That's helpful to think. And OB is such that OB is 4 times OD. So meaning that this is 1/4 of the way along, and this is 3/4 of the way along, because that one's 4 times as long as that one. They also say that AD and BC meet a point E, but that's pretty obvious. We also know that OA equals A overall, and that OB overall is B. So it might be really helpful to redraw that on the diagram. So we know that overall this one is A according to this. We know that overall this one is B according to this. Then, as I said, they said that A is 3 times as long as this one. So therefore that must be 1/3, and that must be 2/3 A. They also said that this whole length here is 4 times longer than that length there. So meaning that must be 1/4, that must be 3/4. So 1/3 plus 2/3 adds up to A, that plus that adds up to B. Helpful stuff. Express in terms of A and or B, OD. Where's OD? OD, look, so we've done the work already. OD is 1/4 B. Done. How about OC? Again, our work's been done for us here. It's going with the arrow again, so 1/3 A. How about CB? Where's CB? CB. So you could go there and there, but we don't know this one, so let's just instead go here to here. So it's like minus 1/3 A plus B. Or as we said, it's the same as CO, vector CO plus vector OB, which is, as we said, minus 1/3 A plus B. And it might be nice. Oh, minus 1/3 A plus B, I didn't change it this time. You might want to write your answers. You could also write your answers as B minus 1/3 A. And the last one, DA. Where's DA? DA, DA. So we could go here to here, but we don't know this one. But we do know this one and this one. So DA is the same as going DO plus OA. And DO, it's going against the arrow, so minus 1/4 B. And this one's going with the arrow, so plus A. So minus 1/4 B plus A. You can rewrite that as A minus 1/4 B. Again, the textbooks sometimes think it's nicer to have the positive at the front and the negative last, in case you're wondering why textbooks might not be writing the answer like that. A minus 1/4 B, or 1/4 B plus A, same thing. Pretty tricky, and thank you very much for your patience with that. And just keep experimenting and trying different ideas is pretty much how you kind of tackle these problems.